In this class, we will know the feature to configure the position representation of parts. Come on. When we move the caliper cursor, we can see that it is limited by a constraint. By expanding the relationships folder and hovering over them, we quickly found that the relationship 17 is a coincidence constraint between these external measuring faces. When we open the edit of this restriction, we see that the maximum and minimum limits have been added. Thus, this restriction allows you to open the caliper to the maximum position, where the cursor collides with the fastening plate. From this restriction that limits movements, we can create what we call position representation. This placement is done in the rendition folder in the position feature indicated by this icon. When we expand the resource, we observe that in this assembly there are 4 position representations. The first is the primary positional representation representing the default state of the assembly. The following are 3 renditions that have been created and configured. With a double click, we can activate the closed representation. Note that once activated, the cursor returns to 0 position and remains fixed to it. The second positioning moves the cursor to an intermediate position. And the third, in turn, fixes the cursor at the maximum opening position. Note that when we change the position representation, some restrictions become inactive, as indicated by the opaque icons. By selecting Constraint 18, we notice that the restrained faces are highlighted in the mounting environment. Selecting the next one, we see that it is about the alignment of the 0 of the nonium with the 100 of the ruler. And finally, the coincidence between these faces. Let's delete these representations and also the assembly constraints and create everything again to better understand how it works. To create a new position representation, we must start by positioning the assembly in the desired shape. In this case, we use the restrict command to create a match between the external measuring faces so that the caliper is in 0 position. Now, on the position icon, we right-click and select New. The new positional rendition is enabled and nested below the main rendition with the default name Position 1. We renamed it Closed. Now, we activate the main rendition and suppress the constraint we just created. We then return to the closed rendition and disable the suppress option. We return back to the main position and save the modifications. Note that now, in the main representation, we have the suppressed constraint so that we can move the cursor freely. When you enable the closed position, the cursor is locked to 0. We also notice that the restriction used appears in bold. This view is typical so that we can easily identify which relationships are being used in the enabled positional representation. Let's create one more position. We renamed it Intermediate. Now, let's use another feature. In the Relationships folder, we click on the coincidence constraint and select the Replace option. In the dialog box, we can enable the Value option and set an offset. We then disable the Suppress option so that the set takes the restricted position. Note that this method is very simple because you do not need to create new constraints to define new placements. This feature allows you to configure all restrictions according to the need for our study or the presentation we want to perform. In this class, we learn how it is possible to easily generate settings for positioning the parts within sets in Inventor. With this feature, we can create studies or presentations of the projects in the assembly file, or even positioning views in the project detail files.